Our goal in problem 1 is to find the antiderivative of the function 6x squared plus 10x times exponential of 6x. Our aim in this problem is to find the antiderivative of the function 6x squared plus 10x times exponential of 6x. Let us integrate the function 6x squared plus 10x times exponential of 6x. Observe that, at first glance we easily see that the function we have to integrate is a product of a nonlinear function, exponential of 6x, with a polynomial function 6x squared plus 10x. Often, when you are faced with this type of complex integration problem, you have to adopt the appropriate strategy that will help you simplify the problem and find the antiderivative efficiently. The two main techniques that we learn in Calculus 2 for solving integrals that involve the products or quotients of nonlinear functions are the U substitution method and the method of integration by parts. The crucial first step of our strategy is to decide which of these two classical methods we should use. In this case, we have a product of a nonlinear function with a polynomial function, so the best method to use is the method of integration by parts. Because this method will help us reduce the complexity of the problem by reducing the degree of the polynomial. It comes that, the polynomial function 6x squared plus 10x is of degree 2. In sum, our first goal will be to reduce the degree of the polynomial function to 1, by using the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v minus the integral of v du. Consequently, we set u equal to 6x squared plus 10x, so du equals 12x plus 10 dx. And dv equals to exponential of 6x dx, and v equals to 1 over 6 times exponential of 6x. As a result, the integral of 6x squared plus 10x times exponential of 6x dx is equal to 6x squared plus 10x over 6 times exponential of 6x plus the integral of minus 12x minus 10 over 6 times exponential of 6x dx. Consequently, we still have to integrate minus 12x minus 10 over 6 times exponential of 6x using integration by parts. Let us integrate the function minus 12x minus 10 over 6 times exponential of 6x. Given that the function to integrate minus 12x minus 10 over 6 times exponential of 6x is still the product of a nonlinear function with a polynomial function, we still have to use the method of integration by parts. The main aim of these repeated utilization of the method of integration by parts is to reduce the degree of the polynomial function, minus 12x minus 10 over 6. In sum, we set u equal to minus 12x minus 10 over 6, so du equals minus 2 dx. And dv equals to exponential of 6x dx, and v equals to 1 over 6 times exponential of 6x. In sum, the integral of minus 12x minus 10 over 6 times exponential of 6x dx is equal to minus 12x minus 10 over 36 times exponential of 6x plus 2 over 36 times exponential of 6x plus a constant c. Now we have to aggregate the results of these repeated applications of the integration by parts to get the final value of the antiderivative of 6x squared plus 10x times exponential of 6x. The first integration by parts gave the following result. So, the integral of 6x squared plus 10x times exponential of 6x dx is equal to 6x squared plus 10x over 6 times exponential of 6x plus the integral of 2 over 6 times exponential of 6x dx. From the second integration by parts, we obtain the following result. So, the integral of 2 over 6 times exponential of 6x dx is equal to minus 12x minus 10 over 36 times exponential of 6x plus 2 over 36 times exponential of 6x plus a constant of integration c. Lastly, combining the last two results, we see that the integral of 6x squared plus 10x times exponential of 6x dx is equal to 6x squared plus 10x over 6 times exponential of 6x plus minus 12x minus 10 over 36 times exponential of 6x plus 2 over 36 times exponential of 6x plus a constant of integration c.